Hi, I'm Doug with Executive Model Design, and I'm going to talk to you today about the Little Brother Hit and Miss Engine Machinist Kit. The Little Brother kit comes with a set of fully dimensioned plans plus the following castings. In the box, you receive a water hopper, a head casting, bearing caps, 2 flywheels, the base, piston and rod, and a set of gears. The cam gear has the cam integrated on it, so that's not an item you have to make. It's pre-machined. The ignition system for this model is very basic. You have a spark plug, a condenser, an ignition coil, and a battery, and a set of points. The points are detailed in the drawings, and you basically make those out of a spring, a insulator, and a piece of steel rod. Spark plug can be purchased from us or some other sources. It's just a standard model quarter 32 spark plug. This is actually a Chinese plug. Some choose to use the old style rim fire. It doesn't have the electrode sticking over the top. I prefer this. It's not very expensive. They're about $15 a piece, and as long as you take care of it, it'll last a long time. This condenser and coil were purchased from an auto parts store. They're fairly standard items. This coil used to be used on a lot of automobiles. The one that springs to mind is the Volkswagen Beetle. This is a 12-volt coil. You can buy a 6-volt coil. Just make sure you get the appropriate battery to go with it. This is not a specific battery. It's just a battery I had that was 12 volts. We typically use 12 volt or 6 volt NiCads in our setup models for display. They're rechargeable and they're easy to maintain. This is the bottom of our display model. You can see the ignition coil, the condenser. This white pack here is the NiCad battery pack. We have a toggle switch here to turn the power on and off for the ignition system. And if we rotate the engine up here, you can see this is an insulator. It might be a little hard to see. I'll show it in further detail later. And there's points here with a spring. The base of the engine acts as the ground, and then the positive hooks to the back side of the other points contact. And as it rotates, the cam not only activates the exhaust valve, but it also closes and opens the points. In the next section, I'm going to try to cover some troubleshooting tips for getting your engine running once it is fully machined and assembled. Most of these things aren't too difficult to do, but you have to get them all in line and where they should be, or it just won't run. It can be very frustrating to get an engine to run the first time. There are a lot of variables. There's machining quality. I know I've machined things in the past and thought I had them just right and ended up making another piece. One of the key pieces is the valve and their seats, and machining that all properly so everything seals so you get compression. The ring, in this particular engine I chose to use a Viton rubber O-ring. Have well over 100 hours on that single ring and have had no issue with it whatsoever. It's a little easier than doing the whole cast iron ring and getting it to seat properly and get proper compression without too much drag. But that is totally up to you which direction you choose to go with that. Let's talk about the head for a minute. The head is a very simple item to machine, but easy to mess up. The holes for the valves, for the valve guides, and then the round parts of the valve guide, plus the hole through the center, all need to be almost perfectly concentric, meaning they have to align with each other. If they don't, it'll be almost impossible, if not impossible, to get this valve to seat. And if you even have a little leak in an engine this small, you're going to have trouble getting it run. It's just as simple as that, especially since the intake valve on this hit and miss engine, there is no rocker arm for it. The vacuum of the piston going down actually pulls the intake valve open just slightly. So this spring is very important. If you have it too strong, the vacuum from the piston going down will not open it and will not draw fuel in. If you have it too weak, it won't seal against the head even if your seat's fairly good. The exhaust valve, this spring is quite heavy, which it should be. You want it to pull it back as hard as possible and seal as good as possible, because the rocker arm is actually going to open that. And the cam actuates the rocker arm to push that open. Can't really show you here, but the seat is very minimal. The hole was machined where the seat would, where the valve would seat, and then a little bit of diamond paste was used on that to work that valve into that opening to make it seat and seal. If you take the head and put it on the cylinder, plug the back of the cylinder and use either an airline or something through the spark plug hole. Actually, not the spark plug hole. You'd have to go through somewhere else. Basically, if you have something covering this, like the water hopper, and the back end had a plug in it that you could feed air into it, when you force air into it, you shouldn't have any leak past the valves, or very, very minimal. You can do a leak down test with airline, very low pressure, just to make sure that you're not getting any leaks past these valves. And then when you push it open, you should hear it pop a little bit to release the air if there's pressure in there. So these are a little difficult to machine. The valves, they have to be concentric. So you mount a piece of rod in your lathe and turn the whole thing without ever taking it out of the lathe. If you have a collet chuck, I do not, but a collet chuck keeps everything much more in line if you have to take it out and readjust and machine something else. But if you have like a 3-jaw chuck, you have to machine the whole thing in place. And it's a little tricky because if you have any bend to this at all, or something's not concentric, it just won't seal. So, in kind of review, just make sure your valves are seating properly. The spring on this intake has to be the right type of wire and not too strong, or it's not going to open and you're not going to get fuel in the cylinder. So this can be a little tricky to do. To set the timing on this engine, you want the engine at top dead center. That means the piston's at the very top that it can be. As you can see here, right here is top dead center. I'm rocking it back and forth past top dead center. Get that aligned. It's kind of an awkward position for me. But at top dead center, you can also see that the piston is not all the way out at the end. There needs to be a little bit in the area in the combustion chamber because you don't want too much compression. The plans give all the dimensions to get the proper size of that, so you have the right compression on this engine to run it. If you get it too high, there's not enough inertia in the flywheels to get past it. If it's too low, it's just not going to compress the gases and ignite them and give you the charge that you need to get it running. So just follow the dimensions on the instructions and you'll be fine. A couple thousandths gasket is fine. You can use copper. I just happen to have a piece of Teflon, and this thing does not run very hot at all. I very rarely even put water in it and run it for 8 hours at a show, and I can still lay my hand on the side of the engine with no problem. But that's running without a load. For display, I just run it with no load, not running any little attachments or anything. I just run it by itself, and it pops and then freewheels for a while and then pops again, and it just does not generate that much heat. These are the timing gears. Getting those aligned with the engine set at top dead center is very